Marina? Marina? Don't have sound.
Hello?
Oh, there you go. Now I can hear you.
Okay, sorry.
I couldn't hear you for a moment there. Can you hear me okay?
Yeah, I can hear you.
Okay. Let's see. I might have opened these out of order. Are we starting with 6? Let me see if the other one starts at 1. It does, but it looks like the other one you've done a lot of.
That was a quiz, so I'm going to do quiz corrections because I do very good on it.
Okay. Shall we start with quiz corrections?
Yeah.
Transformations and graphing of quadratics. All right, let's see. Let's see if I can get the whole thing on here. Okay, so this is what they want you to do, is to make a table whenever you graph one of these.
Yeah.
Okay, which you did. So you have a bunch of points to plot, which you did, and you connected with the dots. Where'd we lose points here? Number 1. Oh, we didn't describe, oh, the domain was all real, and the range was y greater than or equal to 0. Did we lose points here, or is that +2?
Well, it says I got 2 points, but it says it's not completely right still.
How many points would you get if you got it all right? Okay.
I'm not sure. She didn't tell us.
I see what's missing. It says graph the function, which you did. It says describe the domain and range, which you did. And then it says compare the graph to the graph of y equal x squared, which I don't see.
So I didn't do that.
Right. So how would this graph, what's the effect of that 1/3? In other words, if this is y equal x squared, what is 1/3, or y equal 1/3 x squared? What does the 1/3 do?
It made it skinnier.
Makes it flatter or fatter. So it actually makes it like this. If it was y equal 2x squared, that would make it skinnier by half. So when this coefficient is greater than 1, it makes it skinnier. When it's between 0 and 1, it makes it fatter. So I don't know how she wants you to describe it, but you could say, I guess, that it's wider than the parent parabola. It's wider by a factor of 3. Still there?
Can you hear me?
I can now, yeah. Okay, let's look at number 2. Here, the equation is y equal minus x squared plus 3. Okay, which you've drawn a table of. You've plotted it properly. Again, you got the domain correct, the range correct, but we haven't compared it to y equal x squared. So let's take, remember this is y equal x squared. What's the consequence of the negative sign in front of that? What does that do? In other words, our goal is to now figure out how your curve differs from y equal x squared. Still there, Maria?
Can you hear me?
I can, yeah. Not sure how
Okay,
much of
sorry,
what I said you heard,
my computer
but
was shutting down. My computer was shutting down, so I didn't hear anything you just said.
okay.
But it's on now.
Okay. Well, our goal is to compare your graph with this graph here of y equal x squared. So let's do it piece by piece. We've got two differences. Our graph is y equal negative x squared plus 3. So first of all, what is the negative in front of the x squared going to do? It's a reflection over which axis?
The X.
Right. So if I graph this, that's y equal negative x squared. What's the consequences of the plus 3?
It goes up 3.
Right. So I would start with after the reflection, and then I would go up to 3, and my new curve is this dotted curve. So if I'm describing how that's different from y equal x squared, what am I going to say?
It reflects and then translates up the y-axis 3 times.
That's a vertical shift of 3. In other words, the best explanation would be it's a reflection about the x-axis and a vertical shift up 3. And
Right.
notice that it does matter which you do first. No, it doesn't. No, it doesn't. Excuse me. In other words, if I started with this and I moved it up 3 first and then reflected, I would still get what I got. Sometimes it does matter the order you do these, but in this particular problem it does not. Okay, let's go back and look at 3. Okay, on 3 you only got 1 point. Okay. Can you see why? Well, first of all, 3 is missing a table. What happened to the table on 3 and 4?
Oh yeah, the table on 3 and 4 on the back.
Okay, so you have a table, you graphed it. Domain was all reals, that's correct, but the range isn't correct, or is it? Actually, the range is correct. It's, no. Hold on a second, I'm doing the math in my head. Minus 4, yeah, the range is correct. Less than or equal to 16. So your domain is correct, your range is correct. Why did, oh, you only got 1 point instead of 2. We didn't compare it with the other one. Let me show you how to do that. That's a rather complicated thing, but they must expect you to be able to do it. Okay, if I look at my standard equation of a parabola in vertex format, does this look familiar?
Yeah.
Okay. Well, this is very similar to y equal x squared. Only it's got a horizontal translation of h, it's got a vertical shift of k, and it's got a vertical stretch or shrink of a. So if I can get this equation we're looking at into this format, then I'll be able to relate it precisely to y equal x squared. Well, it's a little tough, but we can do it. I'm going to set this 12. I'm going to leave it on the same side of the equation because I want it eventually over there. But the way I'm going to turn the rest of this into that is to factor out a minus 4 and then complete the square. So I factor out the minus 4, leaves behind x squared plus 2x plus 12. You see what I've done? At the moment I haven't changed anything. How do I complete the square inside the parentheses?
Add 1.
Okay, the moment I write a plus 1 in there, what did I do to the right side of the equation?
Subtracted 4.
Very good. Which means I have to add 4 to the same side of the equation so that I didn't change it. In other words, I'm not doing this to the other side of the equation, I'm doing it to the same side. So I subtracted 4 and added 4, which is a net 0. Okay, so now I can rewrite it as minus 4 times x minus 1 quantity squared plus 16. Bingo, that's in the format that I want. So now when I compare this with y equal x squared, let's look at the 4 things we've got going on. First of all, what's the consequences of that negative sign? Just did one? Like that?
I don't remember.
It's reflection across the x-axis.
Oh, yeah.
So we'll start with that. Reflection across x. That's the first thing that's happening. What's the consequences of the 4?
It moves up 4.
It's a stretch. It changes the shape of the curve, and it's a vertical stretch. Vertical stretch by factor of 4. By 4 times. What's the consequences of this 1, this negative 1 right here?
It gets thinner.
It's a horizontal shift, right or left. It's to the right because it's a 1. In other words, the standard is x minus h. Whatever h is, that's the shift amount taking place. And if it's a positive h, it goes to the right. If it's a negative h, it goes left. In this case, it's a positive h, so it's a horizontal shift, not stretch, shift, right 1. And the 4th thing going on in this function is what? The last thing. What's that plus 16 do?
Makes it thinner.
Okay, we need to go over all these. That's a vertical shift plus up 16. Okay. Let's go over every transformation. If I have a standard parabola, y equal x squared, if I say y equal x squared plus 1, what's the consequences of the plus 1? What's it called? Describe it for me.
It vertically translates.
It's a vertical shift. You have two different kinds of vertical movements. You have a vertical shift and you have vertical stretches or shrinks. In this case, because the 1 is way over here on the right, it's a vertical shift, meaning does not change the shape of the curve, merely moves it up by 1. So it would do that. Notice that that is a shift, not a stretch. It does not change the shape of the curve. If I wanted to plot y equal 2x squared, this 2 is a vertical stretch. That does change the shape of the curve and makes it skinnier. But rather than use terms like skinnier or fatter, I would rather, I'm sure your teacher would prefer you saying it's a vertical stretch by a factor of 2. Notice?
Well, I learned that you say like it dilates skinnier.
Uh-huh.
Dilation.
Okay.
And then I also learned
Well, this is not dilation. Right, this is not dilation. Dilation's a completely different thing. There are basically 4 things you can do to a function. You can vertically shift it, doesn't change the shape. You can vertically stretch it, that does change the shape. And the other thing that goes with vertical stretch is a vertical shrink. If I were to vertically shrink this, it would do that. So this curve here vertically stretches it. This curve here vertically shrinks it. And if I want to vertically shift it, I take the exact same curve and just move it up or down. So that's the difference between vertical stretches and shifts and shrinks. There's really only 2 things. There's either a vertical shift or a vertical stretch or shrink. And it depends on whether that constant is added to the function or put as a coefficient in front of it. Okay? Now let's talk about horizontals, because there's the same 2 things for horizontals. There's horizontal shifts, which don't change the shape, and there's horizontal stretches and shrinks, which do change the shape. Okay, if this is y equal x squared, y equal, in parentheses, x minus 1 squared, notice that this is completely different than x squared minus 1. This minus 1, because it is being acted on by the square, represents a horizontal shift. In other words, it's the equivalent of the vertical shift, only instead of moving up or down, it moves right or left. Does not change the shape of the curve. Here's 1. It just moves the vertex. So the curve is exactly the same width, just moved over by 1. And it moved to the right because the format is x minus h. So in this case, h was a positive 1. Positive h's move to the right, negative h's move to the left. Now let's talk about the last thing you can do other than reflect, because you can also reflect over the x-axis and reflect over the y-axis. But let's just talk about vertical stretches, shifts, and horizontal stretches and shifts. We just saw the horizontal shift. Now I'll write a horizontal stretch. Notice that that's not the same as 2 times x squared. This is the quantity 2x squared. In other words, the 2 is part of being squared. So the effects of this too would be a horizontal shrink, and it's the opposite of the vertical. By that I mean when the vertical number is greater than 1, it acts as a stretch. When it's between 0 and 1, it acts as a shrink. Well, horizontally, it's the reverse of that. When you have a number greater than 1, it acts as a shrink. That's a horizontal shrink, made it skinnier. And if it's a number less than 1, say 1/2, then that is going to be a horizontal stretch. It's going to make it fatter. So there's your vertical and horizontal transformations. You need to have those 4 memorized so that you can tell. Let me give you some examples here, and I'm going to have you tell me what they are. So tell me, describe what this is.
It's it vertically shifts up to.
Very good. Now tell me what this does.
It vertically gets skinnier.
Vertical stretch by a factor of 2. And yes, that does equate to getting skinnier, but it's a vertical stretch. Remember those words. Okay, tell me what this does. What's this do?
It makes it horizontally shift down 3.
Well, to the right. If you're going to go horizontal, you got to go either right or left.
Oh yeah, sorry, I meant to the right.
And H is positive. H is a positive 3. And positive numbers translate to shifts to the right. Negative numbers are shifts to the left. So if I wanted to shift to the left, I would do that. If I make it x plus 3, now H is actually a minus 3. Because remember, the standard is x minus H. Okay, and then the last thing, it's the effects of that 4. There's only one thing left. We covered vertical shift, we covered vertical stretch, we covered horizontal shift. What's the 4th thing? Horizontal stretch or shrink. In this case, because this number is greater than 1, it's a horizontal shrink by a factor of 4. Notice that horizontal shrinks are the same as vertical stretches. If I take my parabola and I vertically stretch it, it gets skinnier. Well, if I take my parabola and horizontally shrink it, it gets skinnier. So the horizontal shrink is the same as the vertical stretch. All right, let's go on. Okay, so on number 2, we've got y equal, what is that, x plus 6 squared. Plus, is that a minus 2? Yeah. Now, first of all, we don't want to multiply that out. because we would just have to then complete the square in order to get it back into the format that we want it in. Notice that the format that it's in is y equal a times x minus h squared plus k. What is a? A would incidentally be the vertical stretch factor. What is a in our problem?
Oh, 0
1.
or 1, yeah.
Okay, what is h?
6.
Okay, if it were 6, it would have to read x minus 6. I feel like you have trouble with this concept. If the standard is x minus h, and I tell you that it's x minus 3, then h is 3. But if I tell you that it's x plus 3, then h has to be a negative 3. In other words, the only way that this can be x plus 3 is if I let h equal a negative 3. Then I have x minus a negative 3, which becomes x plus 3.
Oh, I get it now.
You get it now? Okay, good. I could tell that you were having difficulty with that for a while. So in our function here, h is minus 6. And what's k?
Negative 2.
Okay, so now we know exactly what to do. In other words, well, let's see. Let's talk about domain and range. What's the domain?
All real numbers.
What's the range?
Y is greater than or equal to negative 2.
Good. Okay, and now that we know what a, h, and k are, let's compare it with y equal x squared. How does this function compare with y equal x squared? In other words, let's do exactly what we just did as drills. There's only two things going on. We got this negative 2 going on, and we got this plus 6 going on. So what does each one of those do?
Add 2.
Let's talk in terms of vertical and horizontal shifting and stretching. What's the negative 2 do?
It vertically translates down to
Vertical shift.
shift, sorry.
Down 2. What's the consequences of the plus 6?
It widens.
Vertical or horizontal something?
Horizontal
Shift.
shift, there we go.
Which way?
Left.
By 6. Notice that both of these are shifts. Neither one of them is a stretch or a shrink. In other words, neither one of these changes the shape, only changes the position of the curve. Instead of the curve being right here, well, I'm going to move the vertex down by 2 and left by 6. So the vertex is going to be over here, and the curve's going to look like that. In other words, it's really easy to handle shifts. Much easier to handle a shift than a stretch or a shrink. A stretch or a shrink changes the shape of the curve. A shift does not. This is a vertical shift. This is a horizontal shift. All right. Did you get number 5 full credit on that?
No, I didn't get any credit on 5.
On 5? Okay, well let's look at it. Let's look at it then. Here's our height function. I call it a height function because this is going to tell us the height of the ball at any time you want to give me in seconds. That's what t is in seconds. Gives the height of the ball in feet of a football thrown t seconds after it was thrown, or the height of a football t seconds after it's thrown. This equation is basically describing the effect of gravity. Describe the domain and the range. Well, the domain is easy enough. What's the domain?
All real numbers.
Well, really only positive numbers, because time doesn't go backwards. In other words, since t is measured in the seconds after the ball is thrown, it has to be positive. So the domain for this particular problem is that. In other words, you can't always figure out the domain by just looking at the function. You have to understand the function and what concept it's being used in. And in this particular case, time has to be greater than 0. So, what's the range? We know that by this negative sign in front of the 16, that it's a parabola that's going to open down.
So it'd be y is less than or equal to negative 16.
How'd you get set? You put it into minus b over 2a?
Oh, not yet.
Okay. Well, basically we need to figure out, in order to get the range, we need to figure out the coordinates on that vertex, right? Particularly the y-coordinate. Don't really need the x-coordinate, but I do need the y-coordinate. And in fact, looking at the last question, find the maximum height of the football. Well, that's going to be our range, right? In other words, this is the maximum that y can get. That's going to be our range. So if we can find out the coordinates of this vertex, we're going to answer this second to last sentence, and we're going to also answer the last sentence. When does the football hit that height? Well, what's the t-coordinate of that? So if I can figure out the x or the t and the y coordinate for this vertex, I'll answer everything that they're asking. So where is this vertex located?
Well, I got negative 20 over negative 32.
Okay, that's correct. That's the x-coordinate, and that incidentally is the same as 5/8. So the x-coordinate of that vertex is 5/8. I still need the y-coordinate. How do I get the y-coordinate? Plug it in. Plug in the x-coordinate into the function.
So replace x with 5/8.
Replace t with 5/8.
Okay.
Which becomes minus 16 times 25 over 64. So it becomes minus 25 fourths plus 100 eighths, or 50 fourths, plus 6. So we got 25 fourths plus 6. That is 12 1/4. Just to speed things up a little bit. So what that tells me is that this ball was thrown, this football, and 5/8 of a second later, it reaches its maximum height of 12¼ feet, and then it comes back down. In other words, it follows this path that I've drawn. And we know that the time is 5/8 of a second, because that's the x-coordinate of the vertex. We know the height was 12¼ So tell me the range. The range is a little strange also. The range isn't quite what you would read directly from the graph, but it's close. Tell me, if you were reading the range off the graph, what would you say?
I would say y is less than or equal to 12 1/4.
Yes. However, y can never go below the ground level. So in reality, my curve looks like this. And in fact, it came out of the arms of a guy standing 6 foot tall who threw it. So the ball actually starts 6 feet off the ground. How do I know? Well, if I plug in a time of 0, I get +6. So this football starts at 6 feet off the ground. He throws it up. It hits 12¼ feet high and then comes back and hits the ground. So y is less than 12¼ but it's also greater than or equal to 0. It's not just less than 12¼ It can't be negative. There's no way the football buries itself in the ground. Not unless he's really a strong thrower and he throws it really high in the air. And it comes back and plugs. But I was joking. Okay. Do you understand this problem?
Yeah.
Okay. What's this 45 feet?
I thought the 45 feet was when the football hit its maximum height, but it's actually 12 1/4 feet.
Okay. Because one last question that they didn't ask, that they could have, is how far does the football go horizontally? And guess what? We can't even answer that because they didn't give us the angle that he threw it at. So we can't even answer that. So we've killed that problem. All right, let me close this out. And let's have a quick look at this page here. All right. So they want the domain and range, plus they want us to say how this function varies from the square root or from the parent function. The parent function being this function. And that function looks like a v. Notice that when x is less than 0, y equals -x. When x is greater than 0, y equals x. So the absolute value functions look like this. What's the domain on this function? Not the one we're going to talk about here in a second, but what's the domain and range on the function y equal absolute value x? What's the domain? All real. All real. What's the range?
Y is greater than or equal to -2.
No, I'm talking about this one that I drew. The parent function.
Oh, y is equal to or negative to 0.
Y is greater than or equal to 0. Yes. Okay. So the domain on this function here, the absolute value of x minus 2 again, the domain is all reals. What's the range? You gave it.
For which one?
For the problem number 6. What's the range for this? Well, let's graph it, and then you'll know.
Okay.
How do I graph that? What kind of translation? What kind of vertical shift or horizontal shift or stretch is happening?
To the, down to.
Okay, so I'm going to draw that function. That's what this function looks like. Okay? What's the range on this function? Read it.
Y is greater than or equal to negative 2.
Yeah. Okay. And how does this function compare in terms of translations with the parent function?
Y is what?
How does this function compare with the parent function? Because that's what they want. Compare the graph to the graph of y equal absolute value x. So what they're looking for is tell me how this function is translated relative to the first one.
It vertically shifts down to.
Perfect. Okay. What is the domain
All
on...
real numbers.
Okay. What's the graph look like? In order to graph it, let's figure out what the consequences of that plus 3 are. Because this thing only has one thing going on. Right? What is it? What's this plus 3 do?
Horizontally move to the left.
Very good. By 3 units. So this graph's like this. Now tell me domain and range.
Domain is all real numbers, and the range is y is greater than or equal to 0.
So now I think you're getting the hang of what you need to do to solve these. You need to figure out what's going on. Is it a vertical or stretch or shift? Is it a horizontal stretch or shift? Graph it, and then read the domain and range off the graph. As long as you do it in that order, you'll be fine.
Okay.
Okay, let's take this one here.
It gets skinnier.
Hold on. Y equal negative 1/3 absolute value x. Well, there's two things going on. What are they? There's this thing and there's this thing.
It's 1/3, not 1/2.
Oh, excuse me. Thank you. Okay, so what's the consequences of both of those things together? Or one at a time. What's the negative sign do?
It makes it go left.
The negative sign in front is always a reflection about the x-axis.
Oh yeah. Okay.
So if it was just negative absolute value of x, it would look like this. What's the 1/3 do to it?
Makes it horizontally skinnier.
Right, which is called a vertical shrink. That's a vertical shrink. This would be a vertical stretch. But when it makes it skinnier, it's a shrink, not a stretch. Okay. Let's look at this one. We got two things going on here. What are they? Tell me in terms of translations what's going on.
It vertically shifts down 4 times.
Vertically down by 4. Shift.
And horizontally shifts right once.
Beautiful. So now I can draw that. If I got to go right 1, down 4, that's where my vertex is. I got no changing of the shape. It's exactly the same shape as my other curve was. Same shape as this. No making it skinnier or fatter. Domain.
All real numbers.
Range.
Y is greater than or equal to -4.
Correct. You know how to do these now. Now you just got to make sure you don't forget. Okay?
Okay.
Because you definitely know how to do these. Okay, write an equation for a given translation of y equal absolute value x, which is what we've been doing, where it goes 3 units to the right. What would that look like?
You froze. I can't hear you.
Can you hear me now?
Yeah, now I can.
Okay. So what would y equal absolute value of x shifted 3 units to the right look like? What would the equation look like? Instead of y equal absolute value of x, it would be y equal what?
-3, or x -3.
Inside the absolute values or outside?
Inside.
Correct. Exactly like that. Okay, how about 2 units down, 8 units left? What does that look like? 2 units down, 8 units left.
It would be y equals x -2 inside absolute value.
Okay, the inside is the horizontal movement. Outside is the vertical. So the 2 units down is going to be -2 outside the absolute value. The 8 units left has to be inside the absolute value. Is it going to be -8 or +8?
+8.
Marina, you're a superstar. You should know this stuff pat. And if you don't, just review this lesson, this tutoring session. And I guarantee you will pass any test on this material. You should not miss one thing. And perhaps it doesn't matter if you call them vertical and horizontal. Your teacher doesn't seem to call them that. As long as you know what 3 units right, that means a horizontal shift to the right. And 2 units down means a vertical shift down and a horizontal shift left. So as long as you know that, it doesn't matter if you know what the terminology is. At least it might not. All right?
All right.
You have any other questions or anything about any of this material?
I don't think so. I get it now.
Okay. Yeah, look, it seems to me like you do. In fact, it looks like you get it better than anything we've ever done. Um, of all the stuff we've worked on, you've mastered this at the moment. Like I said, the trick is going to be not to forget it. But at the moment, you've got it down pat. Okay?
All right.
All right. Let's see. I am due to see you again Wednesday night at 7.
Yes.
I will talk to you then.
Okay, thank you.
You're welcome. Bye-bye.